بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will begin a new unit, which is the unit of complex numbers. The first part talks about oriented angles. Well, an oriented or direct circle is a circle that has a sense of rotation. In an oriented circle, we see that the anti-clockwise sense is the positive sense. So this is the positive sense, anti-clockwise, and the clockwise sense is the negative sense. So this would be the negative sense. So in an oriented circle, we have a sense. We have the anti-clockwise sense is the positive sense, and the clockwise sense is the negative sense. Similarly, for an oriented or direct plane, it's a plane that contains geometric shapes that are oriented in the same sense. And we can also say that the anti-clockwise sense is the positive sense and the clockwise sense is the negative sense. We will deal with the shapes in a direct plane later in this part of the chapter. U and V are two given vectors in a direct plane. So this is U, this is V. An oriented angle between the two vectors U and V is an angle in a direct plane, and it's denoted by open parenthesis U vector, V vector, and then close parenthesis. So when you see an angle that contains two vectors that are put between parentheses and separated by either a comma or a semicolon, you have to tell that this is an oriented angle. Now, how do we find a measure of an oriented angle? First, we choose or locate any point A in the plane. This is A, and this could be A. Then, we draw 2 points B and C in the plane such that AB equals U and AC equals V. So from A, I'm going to draw a vector AB which is equal to vector U. Remember, when two vectors are equal, they should have the same sense, same direction, and same modulus. Or AB could be KU, where K is a strictly positive real number. So this is B. Now this is vector AC, which is equal to V, and this is vector AC, which is equal to K prime V. It could be, let's say, half V or double V or something like this. So AC is going to be equal V multiplied by a strictly positive real number. Now, we find the measure of the geometric angle BAC. BAC, so we try to find its measure, whether up or down, and we specify the sense of orientation from vector AB to vector AC. If it were anti-clockwise, it would be positive, and if it were clockwise, it would be negative. Now let's go on to the example to clarify the idea. In an oriented plane, ABC is a direct right isosceles triangle such that AB equals AC. Now here, because we are talking about an oriented plane, notice that the labeling of ABC, if I want to label ABC, I'm going to go anti-clockwise, you see. Now find a measure of each of the following oriented angles. So this is AB, this is AC. First, we find the geometric angle in between. Its measure is 90, and we see the orientation from AB to AC. We can see it easily that the orientation from vector AB to vector AC is anti-clockwise, so we have to put a plus here. Now, you're going to see also, dear students, that it's preferable for such angles to be written in radian. Now, the second angle, which is BABC, well, this is BA, this is BC. The geometric angle in this case is 45. This is 45. And if we want to rotate from BA to BC, we rotate clockwise. So that's why it's going to be negative. And in radian, it will be negative pi over 4. Finally, we need the angle CACB. This is CA and this is CB. Also geometrically it's a 45-degree angle. This is 45. Now for the orientation, if we rotate from CA to CB, that's it. We are rotating anti-clockwise, so it will be positive or positive pi over 4 radian. Now application, we have ABC is a direct equilateral triangle with center O. You see also A, B, C. We are going anti-clockwise. You see A, B, C. We are rotating anti-clockwise. Okay. Now find a measure of each of the following oriented angles. Let's begin angle ABAC. Try to do it alone. Well, ABAC, this is the required angle. Geometrically, it's a 60-degree angle. And if we rotate from vector AB to vector AC, we rotate anti-clockwise. So this is positive 60 or positive pi over 3 radian. Now the second angle is OA. OC, its geometric measure is 120 degrees. And if we rotate from vector OA to vector OC, we rotate anti-clockwise, so it will be negative. And finally CB, CA, this is CB and this is CA. Geometrically it's a 60-degree angle, and as an orientation, if we rotate from CB to CA, we rotate clockwise, so it will be negative. Now what are the properties of oriented angles? The first property states if UV is an oriented angle such that UV is alpha radian, then UV has infinitely many measures that differ by 2k pi with k belongs to Z. In other words, an oriented angle doesn't have one measure only. It has infinitely many measures, but these measures are not random. They differ by 2k pi. Let's see what do we mean by this property. We have UV is an oriented angle whose measure is plus pi over 3, or it's a 60-degree angle. Give 4 different measures of UV. So we can say that UV is pi over 3, and we can say that UV is pi over 3 plus 2 pi. Because if we rotate one complete rotation from U to U again, this measures 2 pi, and then if we add pi over 3, we will be back on V. So this is the meaning of 2 pi. 2 pi in this case means one complete rotation, and because we have plus 2 pi, it means we have to rotate one complete rotation anti-clockwise. So this would be 7 pi over 3. Another measure we can, let's say, add 4 pi, and 4 pi in this case is 2 complete rotations anti-clockwise. Again, if we are at U, if we rotate one complete rotation and another complete rotation, this would be 4 pi. We go back to our place, and then if we continue and we stop on V, we will be on pi over 3 plus 4 pi, which is 13 pi over 3. Now we can also go clockwise, complete rotations, and this is expressed as negative 2 pi. We get, let's say, if we are here, if we rotate clockwise one complete rotation, that's it, which is negative 2 pi, and then we go back anti-clockwise for pi over 3 to be here at V, we get negative 5 pi over 3. And if we, let's say, go clockwise 3 complete rotations, which means minus 6 pi, this would be negative 17 pi over 3. So for this property, we are just saying that an oriented angle has infinitely many measures, but the difference between any two measures is a multiple of 2 pi. So you can add as many 2 pi's as you like, and you can also subtract as many 2 pi's as you like, because 2 pi represents one complete rotation. Now application 2. If UV is negative pi over 2, can I say that UV is pi over 2? Remember, in order to tell, you have to find the difference between the two angles. If it is a multiple of 2 pi, the statement would be true. Otherwise, the statement would be false. Try to do it alone. So this is false because pi over 2 minus pi over 2 is pi, and this is not a multiple of 2 pi. For the second one, this is true because 3 pi over 2 minus pi over 2 is 2 pi. That works. Well, this one, minus 3 pi over 2 plus pi over 2 is minus pi, so it's false. And minus 5 pi over 2 plus pi over 2 is minus 2 pi, which is true. And 11 pi over 2 plus pi over 2 is 12 pi over 2, which is 6 pi, which is a multiple of 2 pi, so it's also true. Thank you.